going to start off with three spheres of equal mass, and they're going to combine in such a way that the sphere will move in and hit them equally. So if you ever played snooker before, the center ball here will go in between the middle and it hit both balls off at an angle. Okay, so it comes in here, and then we get the differences between the two centers, and the two balls will go off at angle at speed v. Okay, now what we're going to get here is an equilateral triangle because each distance between them is 2r, and this will mean that it's 60 degrees, and this will mean that the angle, the v values will go in is 30 degrees for argument's sake, diagonal up and right and diagonal right and down, or northeast and southeast for those of you that like the other way of explaining directions. Okay, now what we're going to do next is it goes in a speed u, and because speed u and with an e value of 1/2, and because speed u will name the three particles A, B and C. Okay, now I'm going to replicate this diagram down here. Now the thing about speed u is we're only going to take two particles at a time, because at the end of the day that's what's on your course. Two particles at a time. So imagine that instead of speed u, it's speed u over 2, and we're only taking one particle into account. We're just going to take particle B into account. Okay, and there's particle B there. Okay, now what we're going to do is we're going to get this diagram and we're going to rotate it such that A is going diagonally right down with speed u over 2. Okay, and now we're going to draw a diagram of what A looks like before the collision. A is going diagonally right down at u over 2. That's your 30 degrees. Okay, and now we're going to do u over 2 sine 30 and u over 2 cos 30, and we're going to get root 3 over 4u, and we're also going to get u over 4. B isn't moving, so it's going to grow across at 0, and it's going to go up at 0 as well. Now we're going to do the speeds after collision. We're going to allocate B speed v, because B and C are going the same speed v after the collision, and A is going A's J direction will be unchanged, so u over 4 it remains unchanged, and we're going to use X as the I direction of A after its collision. The top box here is the speeds before collision, and this free region down here is the speeds after collision. We're next going to use PCM in the I direction, and we're going to do m1u1 plus m2u2 equals m1v1 and m2v2. Okay, all particles are of same mass, so we can put in our values here. Root 3 over 4u m plus m times 0 equals mx plus mv, and then we're just going to cancel the m's, and we're going to get x plus v equals root 3. Next one we're going to get is NEL, which is v1 minus v2 equals minus e into u1 minus u2, and then we're going to get x minus v. Now x minus v is basically your v1 minus v2, and that equals an e value of 1/2 minus 1/2, and then it's root 3 over 4 minus u. Now we're going to get a new equation here, which is x minus v equals root 3 over 8. Okay, and we're going to figure out what the x value is first. We're going to get 2x equals root 3 over 8u. When we take root 3 over 4 minus root 3 over 8u, and then we're going to get x equals root 3 over 16u. Now this is the part where I come back in. Okay, and what we're going to do next is going to figure out what the v value is. So v equals root 3 over 4u, take away x, because the x value can go over the other side, and that'd be root 3 over 16u. And then our v value is going to be 3 root 3 u over 16. Is that okay with you guys? Now, so what we do next is that's your v value, and we have our x value. So our v value is 3 root 3 over 16, right? So if you imagine this v value here for b is going 3 root 3 u over 16, and it's going up at 30 degrees. So we have its speed, but what I'd like to know is what is its velocity. So I can do 3 root 3 u over 16 cos 30. So I'll multiply this answer by cos 30, and we get 9 over 32 u. And then if I do it by sine 30 instead, so it's going to be 3 root 3 u over 16 sine 30. So divide this by, and what we get there is 3 root 3 u over 32. Now we have its velocity. The velocity of B after collision is 9 over 32 ui plus 3 over root 3 u over, stop that, postpone please, over 32j. Now phi c is going to be the opposite, except its j component is going to be negative. Okay, so it's going to be minus 3 root 3 u over 32j. Is that okay with you guys? As I said, I've tried researching this online and there's very little on it. One of them was a paid account, so this is what we came up with anyway. Now, regards to the x value, let's sort out what happens to a after the collision. Well, we turned out that a is the x value of root 3 over 16u. But when we rotate that backwards up 30 degrees, so we're going to rotate this back up 30 degrees, we can see it goes directly to the right. So we know the speed of a after collision is going to be, speed of a after collision is going to be, what is it, root 3u over 16. And that's it. That solution makes sense, and it's within the realms of the course. Please remember, you might not be given the e value. So when we used e equals a half back for NEL, that might not be the case. So you might have to carry the e values over. But the remainder of the maths is what you've already know. Okay, alright guys, over and out.